Hello, good afternoon, sir. My name is Chirag Singhal. My registration number is 21 BKT 0181. Here I am going to represent the private blockchain network on my local system in VS Code. Basically, I am creating the blockchain network here. Initially, I am going to show the flow diagram, what I am going to implement right now. Basically, this is a picture of implementing the private blockchain network in my local system. Here, initially, I am going to create the Genesis block which contains block number, which is basically the index of the block, data, which contains the transactions, all the transactions occurred in that block. Previous as this is a Genesis block, so it is the first block in the blockchain, so it does not have any previous S. And hash means this the hash of this block, which is generated using the SHA algorithm. Next, I am going to create another block, which is known as block one, having the data as block data. This is data. Previous hash is the hash of the previous block to connect the block in the blockchain, and hash is the hash of this block. Then we are going to create another block to add in the blockchain. The here previous hash is the hash of just the last block in the blockchain, that is this block 2, and the hash is the block of this block which is created newly in the blockchain. So here I'm going to implement the code of it which I have written right now. So here I have written the code which I am going to illustrate right now. So basically, initially, what we are going to do is we are going to take the SHA algorithm using the module crypto.js slash SHA-256. So for getting this algorithm, we have to write the command in the command terminal or the command prompt as npm install crypto.js. So this command is used to install the dependencies that are required in this code, and the dependency is crypto.js. In the crypto.js module, we are going to take on the SHA-256. Why we are using the SHA-256 algorithm? The main idea of using the SHA-256 algorithm is to get the hash key of the block. Then we are using the stringify from the query string to stringify the hash generated by using the block using the JSON string. Okay. So this is the basic requirements which we are using for creating the blockchain. So initially we have written the code for generating the block in the blockchain. So initially the block, what are the things that should be in the block? So initially the block should be have the index which is going to represent the position of the block. It is going to represent the position of the block. Position of the block. The timestamp is it is used to check when the block is created. When the block when the block is created, this dot data means the data of the block. So this is given the data in the block basically showing that number of transactions occurred in that block. The previous is this is used to check whether the blockchain is valid or not, whether the blockchain is valid or not, and to connect it with the previous block previous block. So and this has the hash of the of this block which is going to be calculated by the calculate hash function. And this nonce is knowing this nonce is basically used to generate or to given the time for creating that block. So initially we are taking 0 because we are only creating the genesis block from the hard code. So initially this function called the calculate hash. So calculate hash is using the SHA-256 algorithm where we are giving this the index, the timestamp, the we are going to convert the data into the JSON string because we in the SHA there are the parameters should be in JSON only. And this previous s we are going to give the previous s of the block. This nonce means time, then all things we are going to convert in a string format. So here, then when we have to create the class blockchain. In the class blockchain, we have to create this dot chain is equal to this dot create genesis block, because we are going to create our first block, which is known as genesis block. And we are going to initialize the difficulty at 4, or we can initialize any difficulty. This is this is dependent on the user reward, on the user reward. If we initialize the dependency low, then the nonce value will also low, because difficulty is showing that you have to differentiate your s values with the previous block. So if the dependency is low, then it takes low time to create the newest value. So due to that, the nonce value will be low. So here we are going to call the function create genesis block. So here the new block, by this function new block 0. What is this 0? 0 here, 0 is the index, timestamp is this, and this is the data, and this is the previous s. We are including previous s as 0. So by doing this function, by calling this function create genesis block, we are going to create our first block in the blockchain. So from this code, we are going to see that our block is created or not. So let's call this node blockchain.js. So here we can see that genesis block is created. So initially our genesis block is created in the blockchain, and this is the index that we have passed in this. You can see here, this is the index that we have passed, this is the timestamp that we have passed, this is the data that we have passed, this is the previous hash, and this is the hash which is generated by the SHA-256 algorithm and converted it to string. That's why it is under semicolon. And this is a nonce. Initially nonce is 0 because we hard coded the nonce for the first block in the blockchain known as genesis block x0, because initially we are providing the generated block to the blockchain. So then if we have to add the new block in the blockchain, then what we have to do? So initially, after that, we have to create the add block function to add a new block in the blockchain. So initially, if we have to add the new block in the blockchain, come to here. If we have to add the new block in the blockchain, then in the previous hash, we have to add the hash of the last block that is present in the blockchain. And in this hash, we have to add the hash of this block, which is newly added in the blockchain. So here, come here. So new block dot previous hash means the hash of the previous hash of the new block is the last block hash. What does it mean? What does it mean? So come here, see that the hash of this block, the previous hash of this block, is the hash of the last block. So what is the hash of the last block? Here it is 00D8C42, and the hash of this block, it is 00D8C42 previous hash. So this is something similar to like a doubly linked list. So here you can see that the new block previous hash is get latest block dot hash. So what does the get latest block function is doing? So you can see here, the get latest block function is doing to fetch the latest or the last block in the blockchain, so that we can get the hash of that block and add it to the newly added block in the previous hash. And here we are going to create our, then we are going to add the mine block function, where we are passing the difficulty to differentiate between the hash. So where is the mine block function? Wait a minute. So this is the mine block function where we are passing the difficulty to add this in the blockchain. So what is basically in this, we are going to add the value, the number of zeros in the prefix of the hash, so that it can be differentiated. So here initially the difficulty is 4, so we are going to add 4 zeros in the initial of the blockchain. So that this chain dot push, this dot chain dot push bracket new block is going to push the new block in the blockchain. So this is the function from where we are going to add the new block in the blockchain. So here we can also verify. So this code is showing that we are going to implement it, the new block in the blockchain. So once again we will run this code, node blockchain.js. So what is this? This is initially genesis blocks is created, you can see in the terminal. Then in the mine block, this is the first block, and this is the second block. In the second block, what is the index? Index is here, you can see 1. What is the time machine? This is same as this, This is same as this. Okay, and this block is 1. And what is this block is 1? And you can see it, the previous hash is the hash of the last block. So this is the last block, genesis block. This hash and this hash is same, and this is the newly created hash for this block. So similarly, we are going to create another block in the blockchain. So here you can see this is the first block in the blockchain. Whose hash is this? This this hash should be the previous hash of the second block in the blockchain. So you can see this is the previous hash in the second block in the blockchain, and this is hash should be the previous hash for the next block that is going to be added in the blockchain. So you can see here this hash, once again make it little big. You can see here this hash and this hash is same, so means our blockchain is same. So this is the newly added block in the blockchain. Okay, so from the code we have created the blockchain network in the private local system. Then we are going to check is the blockchain is valid or not. So for checking the blockchain is valid or not, we are going to create a function which is called as isChainValid. So here we are going. So for this isChainValid, we are going to create start the loop from the one. Why we are going to start the loop from the one? Because we are taking this and this. So we are going to take the block hash of this block, previous hash of this block. If it is not equal to the hash of this block, means the blockchain is corrupted, so it is not valid. So from here we are what we are going to take, we are going to take the hash of the current block, the the hash of the previous block. So we are checking if the current block hash is not equal to the current block hash generated, then it means that the blockchain is corrupted. It means that blockchain is manipulated. So if this case is not there, then we check if the current block previous hash is not equal to the previous block hash, then also it is corrupted. And if all the conditions are not satisfied, then it means that the blockchain is not corrupted, it is true. So we are going to return true. So you can see here it is written true. Initially all the things are true. So if we are going to manipulate the data in the blockchain, then we are going to manipulating the data in the blockchain in the first block. So if we are going to manipulate the data in the block in the first block, like initially in the first block, you can see here the data is this is the block 1. So we are going to manipulate the data. So we are manipulating the data from manipulating the data. Okay, so means the data in the blockchain is changed, so that it means that the blockchain is compromised, the blockchain confidentiality is compromised, so it means that the blockchain is corrupted. So when we are calling the function is chain is valid, then it should be written false. So we can check it here. So when we are going to the when we are going to call the function is chain is valid after manipulating the data, it should be false. Because why it is false? Because initially here the data should be the data is the block, what is the data initially? So initially the data is the block, this is block 1, but when we are going to manipulate it, the data is manipulating the data. So that's why the blockchain is corrupted. So this is the code which I have written in my VS Code only, by using some libraries to check that whether the blockchain can be created in the local system or not. So I have created a blockchain in my local system in VS Code only by using some cryptographic algorithms. So thank you. That's all from my side, and I completed my part. Thank you. Thank you all.